In this video, Math 2 students, we're going to explore horizontal shifts in our parent cubic function. So if you'll notice, we are subtracting 4 here on the inside of the parentheses, which tells me that we have a shift to the right 4 units. Remember, when we have our shift on the inside, that indicates a horizontal shift. So we have a horizontal shift and we're going to go right 4 units. So let's take a look at what that looks like on the graph. Again, I'm going to graph my parent cubic function. And my points are -2, -8, -1, -1, 0, 0, +1, +1, and +2, 8. So that's what my parent looks like. I'm interested in graphing my parent with a shift to the right 4. So I'm going to take each one of these points and I'm just going to count over 4 units to the right. So the points that I did have, 1, 2, 3, 4, 5, are just going to scoot over. 1, 2, 3, 4, whoops. 1, 2, 3, 4, 5. Oops, something has happened here. Oh, I'm only shifting over 4. There we go. That makes sense. 1, 2, 3, 4. And if I draw my graph, what I notice is I have a graph that looks exactly like the parent function, but it is shifted to the right 4. On my cubic functions, my domain is always going to be all real numbers, and so is my range. My x-intercept is super easy to see off this graph. If you'll take a look, there's a point here at 4, 0, because I shifted from 0, 0 to 4, 0. So that x-intercept is really easy to see. But my y-intercept is not so obvious. I'm running off the graph down here, and I can't actually look at my graph and see where I cross the y-axis. So in order to do that, what I'm going to do is I'm going to plug in a 0 for x, because I know that when I'm on my y-axis, x is 0. And I'm going to solve for y. So this would just be -4 cubed, which is -4 times -4 times -4, which gives me -64. And that's why I couldn't see it on my graph. It is absolutely way off this graph that I have on the paper. Way down here somewhere on the graph, I'm going to hit the y-axis. So I would say that my y-intercept is at 0, -64. Let's take a look at problem number 6. Problem number 6 asks us to do a horizontal shift to the left 5. So I'm going to use the same approach by graphing my parent cubic function. And it would look something like this, based on that set of points that we found in the first video. And now I'm going to count to the left 5 units. So 0, 0 ends at 0, -5. And all I'm doing is just going 1, 2, 3, 4, 5 units to the left. 1, 2, 3, 4, 5 units to the left. And 1, 2, 3, 4, 5 units to the left. And here is the cubic function shifted to the left. Again, I've got a domain of all reals, a range of all reals, and I have a y-intercept I can't see. It's going to happen somewhere way up at the top of the graph, so I'm going to have to do some algebra to solve for it. 0, -5. And why did I plug in 0? Do you remember? Because my y-intercept is always going to be where x is 0. So this is just -5 cubed, which happens to be, oh, this is a +5 in my function. So it's +5 cubed, which is going to be a +125. Notice I put in 0 for x's, and I get positive 5 inside my parentheses. And then I take that to the third power here, which gives me positive 125. So my y-intercept is going to be at 0, positive 125. But I believe I can see my x-intercept. If I look at this graph, my x-intercept just shifted to the left 5. So my x-intercept becomes negative 5, 0. So that's it for shifting functions. Let's put several different things together here. If we could describe what's happening in this function, what we'll notice is we're going up 2, and we're going to the right 6. And so I'm going to graph this like I have the others, simply by graphing my parent. Here's my parent. And then shifting all of my points up 2 and right 6. So I'm going to go, let me get my pen, up 2 and right 1, 2, 3, 4, 5, 6. And that's where my origin went. And I'll go up 2 and right 6, up 2 and right 6, up 2, and I kind of end up off my graph 1, 2, 3, 4, 5, 6, and up 2, and 1, 2, 3, 4, 5, 6, and up 2. And there I go. I have my graph shifted to the right 6 and up 2. So again, our domain is our reals. Our range is all reals. To find the x-intercept, I'm going to plug in 0 for y. And this gets a little tricky here. Okay. I'm going to have to subtract 2 from both sides. And now I take the cube root of both sides. So I have the cube root of negative 2 is equal to x minus 6. And I add 6 to both sides. So I end up with 6 plus the cube root of negative 2. And that's actually where my x-intercept is going to be. I could actually write that as an ordered pair. 6 plus the cube root of negative 2, comma, 0. But more commonly, we're going to go ahead and turn that into a decimal so that we can graph it. So if I take the cube root of negative 2, that's like taking negative 2 to the 1/3 power. And when I do that, I get negative 1.26. So I'm going to take 6 and subtract 1.26, and I get approximately 4.74. So if I wanted to list my x-intercept, I would say my x-intercept is at approximately 4.74, 0. And if you look at our graph will show an x-intercept that looks like it's about at 4.74. Now I have to do the same thing to find my y-intercept. So I'm going to erase these so I have some room to write. You can always come back or take notes on some other piece of paper nearby. To find my y-intercept, I plug in 0 for x. And this algebra is a little more straightforward. That's cubed. So I have negative 6 cubed plus 2. So if I take negative 6 to the 3rd power, I get negative 216. So my y-intercept is at negative 214 here. Let me move the camera so you can see a little better. I plugged in 0 for x. And then I took negative 6 to the third power, which happens to be negative 216, and then added 2. So my y-intercept is actually going to be a point at 0, negative 214. And that's it for shifts.